In this video, we're going to take a look at some practical ways that scientists can use to measure reaction rates in the lab. So far we've just seen concentrations given to us, and that was essentially it. But now we're going to take a look at how do scientists actually measure these reaction rates. And ideally, scientists want to choose something that is an easy method for them to use and that will not interfere with the reaction itself. And the method you use sort of depends on the nature of the reaction that you're looking at. So for example, let's say we take a look at this reaction over here. You will notice that there's some gas produced in this reaction. So a nice easy way to monitor the rate of the reaction might be to look at perhaps the change in pressure over time, because as you produce more gas, the pressure increases. So you can monitor changes in pressure, and you can use a simple tool like a pressure sensor, which allows you to monitor the changes in pressure over time. And that's especially the case when you have reactions where gases are involved. Now let's look at this same reaction over here, where again we have a gas that's involved. One other thing that you could do to monitor this rate is maybe instead look at the change in volume over time. So here's the reaction vessel. As the gas is produced, it's going to go into this separate area over here where you had a test tube filled with water. And the idea is that as the gas is produced, it's going to kick the water out and the gas is going to take its place. And so you can monitor how quickly the volume is being displaced. So you can look at a change in volume over time. So when gases are involved again, you could, rather than look at the pressure, if you don't have a system to measure pressure like a pressure sensor, then you could use a syringe that can monitor your volume change as the gas fills up the syringe. It will increase the volume there, or you can monitor the volume displacement. So those are two ways that scientists will often monitor the rate when gases are involved, looking at the change in pressure over the period of time, or the change in volume over the period of time. Another thing that you can monitor is conductivity. So if we take a look at this reaction over here, you'll notice that we have ions that are produced. And generally, as ions are produced, the solution becomes more conductive. So you can take a look at the conductivity changes over time, and you can use what's called a conductivity meter. Essentially, with more ions made, your solution becomes more conductive. So change in conductivity is another way that you can monitor the rates of reaction in an easy way for a reaction where ions are involved. Now let's take a look here. Ions are involved here as well, but the charge doesn't really change over here, over here, over here. So it's not like you're making more ions or less ions. So conductivity for this equation over here may not be the best approach. In the previous equation, notice there were no ions, and then all of a sudden ions were made. And so that made the solution more conductive than before. There was a change in the conductivity. There may not be here. It's hard to tell because you have the same sort of number of ions every single time. But what you may notice that's a bit different, though, is the color. These two reactants are colorless, and so is this product here. But this product is yellow. So what you could monitor as well to give you an idea of how fast your reaction is going or how slow it's going is the change in color. Now, typically to monitor change in color, we use a special machine called a spectrophotometer, and it basically just monitors color by looking at how your substance absorbs and reflects light. So that's why you have the change in absorbance over time, but that's a fancy way of saying monitoring the color. So if you see that, something at the beginning has a different color than at the end in the products, then maybe a good technique you might want to use would be to monitor color using a spectrophotometer to give you absorbance readings. Another reaction that we can take a look at is this one over here. So yes, we have a gas being produced. So if you have a gas being produced, you might look at the displacement of the volume, you might look at pressure, but another thing you could do is take a look at the change in the mass over time. So in this reaction here, we have the reaction vessel on a balance. As the CO2 is produced, it may escape the vessel, and then you'll see the mass will decrease. So you can take a look at that rate of mass decrease or increase, depending on where your gas is going, over that period of time. And typically to do that, you just need a nice electronic balance to monitor those changes. And although this is not a complete list, we're just going to end at this last one over here. You'll notice in this chemical reaction, you have an acid that's produced. And when you have an acid that's produced, you're going to change your pH of your solution. So you can also monitor the pH of the solution and see how quickly that's changing. Whether it's becoming more acidic or less acidic due to bases, you might want to monitor pH change as a way to give you an idea as to how fast or slow your reaction is going. So you can use a pH meter, which is what you see over here, that will record the pH throughout the reaction, rather than trying to dip litmus paper in over and over again and trying to that won't give you an accurate reading, because you're getting the paper in, trying to read it. There's just way too much gap time in between. It won't work. So you really do need to have a pH meter to allow you to use this technique. Essentially, the more refined your equipment is, the more it can give you the data in a continuous way, the more reliable your rate data will be. There's other ways that you can monitor rates of reaction. So for example, maybe you might look at the change in temperature over time if you're dealing with endothermic, exothermic style reactions. It just depends on the reaction that you're looking at. Your goal right now is to be able to explain the main ways we discussed here, to perhaps select the most appropriate measurement for a specific reaction. So if I give you a reaction like this, can you tell me, well, you know what, since there's a gas, pressure, volume, maybe mass as well might be good. Or if I give you something like this, there's ions that are made and there were no ions before, there might be a change in conductivity. If you see acids or bases being made, maybe change in pH. If you see different colors, maybe monitoring the color through absorbance. You might not know the colors of all the chemicals, but I would show you a picture, or I would indicate that as a clue for you to realize, oh, changing color is something I want you to monitor. So again, this little video lesson here was just on the different methods that scientists can use to monitor reaction rates in the lab. And essentially, they just want to choose something that's easy for that reaction and that won't interfere with the reaction itself.